Hello everyone, my name is Benjamin Gotch, and welcome to the second episode of Geology in KSP. Today's episode, we're going to take the data that we've gathered from the Culver's program in my last video, and we're going to begin forming theories on the formation and the makeup of the Minmus Flats. Let me know down in the comments if your theories about it were proved or disproved due to my data gathering, or any other interesting findings that you may have throughout your own experimentation. The Minmus Flats are an interesting question. They are completely flat. All across the surface, they are at 0 meters elevation. They have no rocks unless they are near one of the hilly regions, such as the lowlands or the midlands. And they have no discernible surface features. They are useful for helping in navigation, as the different shapes of them can help mark out regions around them to help navigate around the planet. But the flats themselves are a mystery. It is very rare in the universe for there to be a completely flat surface. Often, surfaces like Minmus Flats will be exposed to tidal forces that cause earthquakes and cracks. They'll also be exposed to meteorite impacts from small or even large pieces of planetary debris. How do the Minmus Flats remain, flat? Well, to put it simply, there are two ways that they could be doing this. One, the surface is sublimating away, similar to how dry ice will go from a solid ice-like structure to a gas. The surface could sublimate away as it gets closer to the sun, shrinking the flats away and erasing any of the interesting features that would show impacts or any fault lines. Or, just as interestingly, the Minmus Flats could be a solid layer of material resting upon a liquid lake. There are several different ways with which we can test these hypotheses, and we tried two methods in the Culver's program. There are two methods at which we used to gather this data that we needed. The first method was to test the theory of sublimation. We sent a crude Culver's spacecraft, known as Culver's 1, with pilots Jebediah, engineer Bob, and scientist Bill Kerman to the surface of Minmus in multiple locations. Their job was to try and find out what the material that made up the Minmus Flats was made out of. And they were able to land in two separate locations and perform two different tests to see what they're made out of.
Steady, Jeb. Okay, keep it slow, and touchdown. Okay, Houston, making my way to the surface. Everything seems to be like icy. Gathering the sample now, it looks so much like ice cream. I'm just gonna eat it. I'm sorry. I'm gonna eat it once I get inside.
The second method that we used to test our hypotheses was to send a uncrewed probe with a seismic sensor to attempt to detect earthquakes. We would land a probe in both flat lands and in lowlands, midlands, and highlands in order to test to see if it could pick up earthquakes at different levels in the different regions. which could show what the materials are beneath the surface of these regions. So after these experiments were performed, what did we learn about Minmus? Well, first we learned that Minmus is not edible, but more importantly, that it does not appear to sublimate away. The second is that there are moonquakes that are present at greater intensities when we are landed in the flats. So what does that tell us about the flats of Minmus? Obviously, it tells us we can't eat Minmus, and that the surface of the flats doesn't melt or sublimate away. We've also found green sandstone, and found that the surface is made up of icy crystal structures within the regolith. Combine that with the moonquakes that are increased in intensities at the flats, and we can assume that the Minmus flats are in fact frozen lakes. So how can we theorize, with the seismic data that we've gathered, that the flats are in fact a frozen lake with a liquid layer underneath? Well, it goes into answering the question as to why the moonquakes become more intense at the flats. This is because solids and liquids absorb vibrations in different ways. Solids, like the rock and frozen materials that make up the surface of the Minmus hilly regions, absorb and reflect vibrations much more than a liquid would. This, in fact, is the same method that was used to discover that the mantle of the Earth was liquid, while the core was a solid. In my description, I've got a link to an article about that exact discovery. But since we found that the quakes were stronger at the flats, we can make a theory that the flats are the solid top layer of a liquid lake. While the crew did not find evidence of sublimation, they did find some evidence of the frozen lake theory in the form of the breaking grounds expansion material known as green sandstone. While not a lot of information is gathered when you gather up green sandstone, it is useful in looking at it to form hypotheses about where the sandstone formed. I believe that the green sandstone is formed in the flatlands, that it is initially material formed from the flatland material. It is then ejected away from the flatlands and impacts with the surface of Minmus again after meteorite impacts. The layering we see in green sandstone that gives it the name green sandstone is the different layers of the material as the liquid underneath would leak up and freeze atop the surface, forming the several different layers that we see throughout it. But there is really no stock way to prove this theory. If at some point Squad wants to add core sampling tools to the stock game, that would give us this information to prove my hypothesis correct, then we'll be able to test it. But until then, this is just a hypothesis. I want to thank you all very much for watching this video. This has been an interesting experiment in my video production process to see what works and what doesn't. I've hoped you've all had an opportunity to learn something new, and I hope you've enjoyed this video. If you'd like to, next video we're going to be going to Duna to gather data on the origins of the Duna crater. The Duna Canyon, and we'll begin learning about the different ways that canyons can form. And I'd love it if you would leave your comments down in the description below, or down in the comments. Just let me know what your hypothesis is about how the Duna Canyon formed. This is now the part where I'm going to start plugging my social media. If you'd like to, I'm most active on Twitter, but I do have a Facebook page for this channel as well as a Discord server. And if you'd like to try and if you want to support my channel, you can go on to Patreon, where if you donate any amount at all, I will name a Kerbal after you that will be used in my videos. As always, leave a comment if you have suggestions or questions, and give it a like if you enjoyed. Subscribe if you want to see more videos just like this involving science, engineering, and space travel. And join me next time as we explore Duna.